All right, so today we're going to learn the third and final method to solving quadratic equations. Now, you might wonder why we need a third method, and the reason for that is not all quadratic equations can be solved by isolating the variable. Also, not all quadratic equations can be solved by factoring because there are some polynomials that cannot be factored. This does not at all mean that there's not a solution. What it means is that the solution is an irrational number. So here is the quadratic formula. You want to make sure you write it down perfectly. It is x equals negative b plus or minus the square root of b squared minus 4ac, the entire thing, divided by 2a. All right, so you might recall that the general form of a quadratic equation is ax squared plus bx plus c equals 0 or equals y. So let's write that. Ax squared plus bx plus c equals 0. It could also say equals y there. Now, the formula up here, we are plugging values in for a, b, and c to get my solution, right? So the value of a is always going to be the coefficient of x squared. The value of b is always going to be the coefficient of x. And the value of c is always going to be your constant. Now, in order for it to work, there are three things that you have to remember, and I put them over here. You have to make sure that your terms are in order. So it should always go the x squared term, then the x term, then the c term. You have to make sure it's equal to 0. Just like factoring, this method doesn't work unless the whole equation is equal to 0. And then if you're missing a c term or a b term, you put 0 into the equation for that variable, okay? So the next question is, when can I use the quadratic formula? You can use the quadratic formula to solve any quadratic equation, okay? So let's go ahead and write that. To solve any quadratic equation. And reminder, what makes something quadratic is that it's a degree of 2 and the highest exponent on your variable is 2. So it has to have an x squared and nothing higher than that in order to use the quadratic equation. So let's go ahead and solve the first example. So the first thing you always want to make sure is that the whole thing is equal to 0, which this one is. And then you have to decide, what are you plugging into the equation for A, what are you plugging in for B, and what are you plugging in for C? So the A is always the coefficient of x squared, so A is going to be 2, just the number 2. You don't put the variable on it. B is the coefficient of x. You have to keep the sign in front of the number, so B is going to be negative 4. And c is your constant. So that's going to be negative 5. All right, so I popped the formula there again. I know you can still see it. What we're going to do now is we're just going to fill in what numbers go in for a, b, and c. So I'm going to say x equals negative b. Negative b means the opposite of b, right? So since b is negative 4, we could write negative negative 4, but you could just simplify in your head, well, negative negative 4 is positive 4. Plus or minus, and we'll talk about what the plus or minus means at the end, okay? The square root of b squared, so since b is negative 4 and you're squaring it, remember, you have to put negative 4 in parentheses squared. You also right here could in your head say, well, negative 4 is 16, so you could just put the number 16 there. Minus 4 times a is 2, times c is negative 5. And I'm going to extend my radical symbol there because everything is under this radical. The whole thing is now divided by 2 times a. So I'm going to do 2 times the value of a is 2. So now I have to simplify this whole thing. We have to follow the order of operations. So I have to do what's inside grouping symbols first. your radical symbol is a grouping symbol, so you have to do what's inside there first. So I have to do negative 4 squared minus 4 times 2 times negative 5. So I'm going to go ahead and do negative 4 squared first. So I'm going to rewrite that I've got 4 plus or minus the square root of 4 squared is 16 minus 4 times 2 times 5. The whole thing over, I'm going to go ahead and do 2 times 2 now because that's going to be 4. Okay? Oops, I forgot my negative sign. Times negative 5. So now what I have to do is the multiplication. Now this is tricky, right? Pay very close attention. You're going to do 4 times 2 times negative 5, which is going to give you a negative number, and it's going to be minus a negative number, so it's really going to be plus a positive number. The other way to look at it is you could do it as negative 4 times 2 times negative 5. So think about that. Well, I rewrite it, x equals 4 plus or minus the square root of 16. Well, since 4 times 2 is 8, 8 times negative 5 is negative 40, but since it's minus negative 40, that's actually going to be plus 40. The whole thing over 4. Next step, you have to do 16 plus 40, right? So I'm going to put my work up here now. So now I have x equals 4 plus or minus the square root of 56 over 4. All right? Now, the square root of 56 is an irrational number. So what I have to do now is I have to simplify that radical. Okay, so we got to go back to simplifying radicals. We're looking for a perfect square that goes into 56. And I'm just going to tell you right now, it's 4. Okay, 4 goes into 56. So we're going to break that into the square root of 4 times the square root of 14. We're going to find the square root of 4, which is 2, right? So I'm going to get x equals 4 plus or minus 2 square root of 14 over 4. Now, we're still not finished. We're still not finished because we now have to simplify the fraction. Now, let me also mention that the plus or minus here, this plus or minus is representing two math problems. So what this would mean is 4 plus 2 times the square root of 14 divided by 4 is one solution. And the other solution is 4 minus 2 square root of 14 divided by 4, okay? But we do want to fully simplify it because what I want is the fully simplified version, and then I'm going to show you how to get the answer using Desmos calculator, okay? So remember, this is a term. Terms are separated by addition and subtraction signs, so that makes 2 square root of 14 a term, and the whole thing's being divided by 4. Since all of these terms are all divisible by 2, you would divide all three of these numbers by 2, not the radical, because the radical is part of the term 2 squared of 14. So 4 divided by 2 is 2. 2 divided by 2 is 1, but it would be 1 squared of 14, so it would just be 2 plus or minus the square root of 14 over 4 divided by 2 is 2. Now, you would only do that if all three of those terms are divisible by the same number. So this is the exact simplified version of this equation. If I wanted to get an estimate, I would split it up, right? So now you're going to get the estimate. So I'm going to say the estimate is going to be x equals 2 plus the square root of 14 over 2. And the other one is x equals 2 minus the square root of 14 over 2. And this is when our calculator comes in handy. All right, so let's go ahead and just pop in this graphing calculator. I just went to Desmos. It doesn't matter if you go to Desmos or desmos.com or the testing one, it doesn't matter. And I'm just now going to start typing in my first problem. So I'm going to type in 2 plus, you type SQRT to get the square root symbol, 14. And now I need to divide the entire thing by 2. So what I have to do is I have to highlight the entire thing. I'm going to hit the division key, and then I get that fraction bar divided by 2. Now, we get this irrational answer here. We're going to round that, to the hundredths place. So that is one of the values for x. We're going to make that 2.87. Now to get the next one's really easy. All I have to do now is I just have to change that plus sign there to a minus sign, and then boom, I get my other one. My other answer is negative 0.87, rounded to the hundredths place. And so those are my two estimated solutions. So now we can record those two solutions, and I'm going to put them in set notation. The first one, well, the second one was negative 0.87, and then the next one was 2.87. And I just put them in order from least to greatest. It doesn't matter really which one you do. So that's my estimated, and that's my exact, and you got to understand both of them. So this would be the point in which I would stop the class right now and we would stop and sing the quadratic formula song. However, I'm going to save myself some embarrassment and not do that right now, but do let you know that there are two links of two fun songs about the quadratic formula that will help you memorize the quadratic formula. So feel free to watch those when you're finished. I also want to let you know that you're not required to memorize the quadratic formula. However, the more that you use it, the more likely it is that you're going to just know it. So you will always be given it. Let's go ahead and take a look at the next problem. Okay, so I know it might feel like these problems take a really long time, but the more that you do, the easier they become. So I'll walk you through this next one. However, if you feel like you've got it, feel free to stop the video and give it a try and then come back in to see if you've done it correctly. So first step, you have to make sure the whole thing is equal to 0, which this one is. Then you need to identify what A, B, and C are. Now, it did take me quite a while to explain the first problem. They're all not going to take that long. It's the more you do, the faster you're going to get. So if you feel like you understood the first example, feel free to stop the video and give this one a try. All right, so the first thing you need to do here is make sure the whole thing is equal to 0, which it is. And now you have to decide what A, B, and C are. So the value of A is always the coefficient of x squared. It's always going to be a number. The value of B is always the coefficient of x. It's going to be a number. And the value of C is always going to be your constant. So we should have gotten 4, 2, and negative 5. So now we're going to plug them into the quadratic formula. And I'm going to do some simplifying as we go. So first thing, I'm going to start with x equals, start with negative b. So negative b would then be negative 2 plus or minus. The position of that plus or minus is important because I'm going to do negative 2 plus the radical and then negative 2 minus the radical. Okay, so now we have the radical. So it's going to be the square root of b squared. Since the value of b is 2, I'm going to go ahead and square it in my head. 2 squared is 4. Then I'm going to do minus 4 times ac. So a is 4 and c is negative 5. Extend that radical symbol so that it goes over that entire expression. Then I'm going to divide the entire thing by 2a. So 2 times a would be 2 times 4. I'm just going to go ahead and do that. That's going to be 8. Now, I want to just point out that right here, somebody might be like, well, can I reduce the 2 and the 8? And the answer to that right now is no, because this negative 2 is going to be added and subtracted to whatever this is. So remember, the order of operations says you have to do the top before you divide. So you cannot do that. That's illegal because you can't cross things off between addition and subtraction signs. Okay, so we just have to now follow the order of operations. So what we're going to do is what's inside here first, which would be the multiplication. So I'm going to do my multiplication of these three numbers first. You can multiply them all at the same time. Now, the tricky part here is you got to pay attention to this being a subtraction sign. So you can look at this two ways. You can look at this like you're doing positive 4 times 4, which is 16, and then 16 times negative 5 gives you negative 80, but then you have minus negative 80, which would then in turn mean I'm adding 80. Or if it helps you, you could look at this negative 4, like it's a negative 4 times 4, which is negative 16. times a negative 5, which is going to give you positive 80. So then this whole thing right here is a positive 80, which means it's getting added to the 4. Whichever way makes the most sense to you, but you have to pay really close attention to your signs here because that is the biggest mistake that people make. So what I end up having is negative 2 plus or minus. Inside the radical, I'm going to have 4 plus 80 because it was minus a negative over 8. Now I have to do 4 plus 80, which is 84. So you get x equals negative 2 plus or minus the square root of 84 over 8. Now that radical right there is not a perfect square. So I have to simplify that radical. So I'm looking for a perfect square that goes into 84. So since both 8 and 4 are both divisible by 4, and 4 is a perfect square, I'm going to think through that first. So 84 divided by 4 gives me 4 times 21, right? So I'm going to break this into the square root of 4 times the square root of 21, and the square root of 4 is 2. So that leaves me with x equals negative 2 plus or minus 2 square root of 21 over 8. So now that I've simplified my radical, now I can reduce, right? So now it's negative 2 plus or minus 2 square root of 21. This 2 square root of 21 is one term, and the coefficient would be the 2 divided by 8. All three of these numbers are divisible by 2. So now I would take it a step further, and I would divide it. So negative 2 is divided by 2 is negative 1. So I'm going to move my answer right up here, over here. So I'm going to get x equals negative 1, which is important to have that negative 1 there, plus or minus 2 square root of 21 divided by 2 is just the square root of 21. You could say 1 square root of 21, but since the 1 is being multiplied by the square root of 21, you don't need it. Okay? You needed the negative 1 at the beginning because it's being added and subtracted to the radical 21 over 4. So this is our exact answer right here. It's irrational again because the square root of 21 is not a rational number. So now we're going to get our estimate, and we're going to get our estimate by splitting it up. This represents that x is equal to negative 1 plus the square root of 21 over 4, and x is equal to negative 1 minus the square root of 21 over 4. So now I'm going to go to Desmos and I'm just going to type those expressions in and see what I get. So I'm just going to go back to Desmos and I'm just going to type over the problem I already have here. I could exit out, which is fine, but I'm going to change the 2 to negative 1. And I'm going to change that to a plus. And then the square root of 21. Quick reminder, you can get square root by going down here and choosing square root, or you can just type in SQRT. But mine's already there, so I'm just going to change that 14 to a 21. And that's going to be divided now by 4. And you'll see my irrational answer here. Now we're going to round that to the hundredths place. So notice it says 0.895. So that's going to round that 0.89 up to an 0.9. But because I want to round it to the hundredths place, I want to have a digit in the hundredths place. So we're going to make that 0.890. All right, now let's go back and just change that minus sign to or that plus sign to a minus sign, and then I get negative 1.395, which is going to round up to negative 1.40. So putting my solution now into set notation, my estimated answer is going to be negative 1.40 and 0.90. So that would be my estimated answer. Now, if you were hoping to do a check for this to see if this would work, you could plug in your estimates, right? Like if I put 0.90 in for x here, you would not get perfectly 0, but what you would get is an answer really, really, really close to 0. Okay, so if you were trying to check to see if your answers were right, you could plug them in, but just know because you're estimating, you're gonna get an estimated check. So taking a look at number 2. For number 2, before we start the problem, we do have to get this entire thing equal to 0. Now, many of you might look, well, let's just move this 2x squared over here by subtracting the 2x squared. One reason I would not do that, it benefits you to keep that first term right there, positive, the x squared term, because if you think about what you're going to end up doing 2 times a. If your a is positive, you're going to have a positive number in the denominator, and that's better because if you have a negative number in the denominator, then at the end you have to pop that negative sign up to the top, which is totally acceptable, but sometimes just gets lost in translation. So when we do this, to get the whole thing equal to 0, I'm going to move my x to the other side and my 15 to the other side, which means I'm going to subtract them. So now these two terms become negative. So before you start this problem, you need to make it 2x squared minus x minus 15 equals 0. All right, so now plugging it into the formula. A is going to be 2, B is going to be -1, and C is going to be -15. Now, if you already tried this problem without me and you brought the 2x squared over and made that negative, that's fine. I'll kind of just talk about at the end. Your answer should at the end look the same. So I'll mention that at the end. So I'm going to say x equals -b. So that would be -1, which I'm going to simplify to +1, plus or minus the square root of b squared. I'm going to do that in my head. -1 squared. -1 squared ends up becoming +1. So I have 1 minus 4 times a. A is 2 times c. C is -15. The whole thing divided by 2a. So 2 times 2 is 4. All right? So now I have x equals 1 plus or minus. You have to multiply all this together. So I like to look at it as -4 times 2 is -8, and -8 times -15 is +120. So what I'm going to get inside my radical is 1 plus 120 over 4. And now I'm going to do 1 plus 120, which is 121. So I get x equals 1 plus or minus the square root of 121 over 4. All right, so this problem right here, because the square root of 121 is a perfect square, and you get 11, we don't need Desmos for this. We can just do the problem, right? So the square root of 121 is 11. So now I'm going to make the problem x equals 1 plus or minus just 11, right? We no longer have a radical because the square root of 121 is 11 over 4. Now, this answer is not irrational. It is rational. So my answer, I'm just going to have an exact answer, right? There's not going to be any estimating that has to happen. So now I'm going to do 1 plus 11 over 4, and then I'm going to do 1 minus 11 over 4. And these two expressions are going to give me my answer. So we just do the math. On the top, 1 plus 11 is 12. 12 divided by 4 is 3. So I get that x is equal to 3. And then I'm going to have 1 minus 11 is -10. -10 over 4 is going to give us -5 over 2. So we have x is equal to -5 over 2, or -2.5. So putting my answer in set notation, I'm going to get -5 over 2 and 3. And that's my answer. Now this one, because I didn't have to estimate my answer, and my answer is a rational number, if I wanted to plug these solutions in for x, it should work perfectly. All right, so if this right here, this b squared minus 4ac, that's called your discriminant. If that number is a perfect square, that means that your answer will be a rational answer, and you don't have to do any estimating. You just keep doing the problem. Now, if you had left everything so that your denominator was negative, you still would have gotten these answers. You would have gotten 12 over negative, or -12 over 4, -4, which gives you 3. And then you would have gotten +10 over -4, which still gives you -5 over 2. So at this point, I do recommend that you stop the video and you try this one 100% on your own. Quick reminder, your first step is that you have to get the whole thing equal to 0. So stop the video, give it a try, come back in and see if you've gotten it correct. So Here's what you should have gotten. You should have gotten both an irrational exact answer and a estimated answer. So you should have gotten 1 plus or minus the square root of 13 over 2. And then when you plugged those into Desmos, your estimated would be negative 1.30 if you're rounding to the hundredths place, and then 2.30 if you're rounding to the hundredths place. So again, just a reminder, the reason I'm putting the 0 there is a placeholder because I'm asking you to round to the hundredths place. So if you got it wrong, pay attention to my work and see if you can figure out where you made your mistake. I did give a little bit more steps than usual. So this is me filling everything into the formula as it should go. Reminder, when you're squaring a negative, you have to put that in parentheses. So if you are doing this on a calculator and you want to square -1, you have to remember to put parentheses around the -1, okay? I personally would have just started with this step by squaring it in my head. And then once I got that this was positive 12, I would have added it to the 1 to get the 13 in my head. So if you're pretty good at this, you can just maybe do that step and go straight to that step. The reason I don't have to take this any further is because the square root of 13 doesn't have any perfect squares that go into it. So you just stop there. All right, let's go ahead and take a look at the next one. All right, so for this next one, again, before you start, you have to remember to get the whole thing equal to 0. So go ahead, get the whole thing equal to 0, and then come back and see if our answers compare. I will tell you up front that there is something a little strange that happens in this problem, and I want you to think about what it means when you get there. All right, so for this one, hopefully you noticed that the number under the radical is negative, right? So I can't find the square root of a negative number. So what we would say in this case is that the value of x there's no solution. Now, when you get to algebra 2, you are going to simplify this into an imaginary number. So if the radical, the discriminant in here, the b squared minus 4ac ends up being a negative, that means that your solution is imaginary, which we don't get into in Algebra 1, but you will. So for Algebra 1, we're just going to say that there's no solution. All right. If you got it wrong, take a look at my work. I showed a lot of work over here, so you can see if you can figure out what you did wrong. So to end this lesson, I want to just review all the methods that we have learned to solve quadratic equations. So the first method we learned was called solve by using the square roots method, or I refer to as just solve by isolating the variable. So quick reminder, you can't do that if you have a b term, an x term. So in this particular case, this problem number 5, 4x squared plus 25 equals 0, you absolutely can solve this equation by isolating the variable or using the square roots method. The next method we learned was solving by factoring, right? This can only be done if the polynomial that you have there is actually factorable, right? So this one, 4x squared minus 25, that's a difference of squares. So you can solve that by factoring. And then the last method is the quadratic formula. You absolutely can solve any quadratic equation using the quadratic formula. So if you are unsure as to what method to use, you can go to the quadratic formula and it should work for you every single time. It just sometimes takes a little bit of time. So what I want you to do is I want you to practice this problem. I want you to first solve it by isolating the variable. Remember, you isolate the variable first and then you find the square root of both sides. And then I want you to solve by factoring. And then I want you to solve it using the quadratic formula. You should get the same answer for all three, using all three methods, because it's the same problem. And my dog is going a little bit crazy in the background. So I'm going to stop the video, and I want you guys to also stop the video and give it a try. Okay, so all three times you should have gotten that the answer is plus or minus 5 over 2 or plus or minus 2.5. Take a look at my work. It's very important that you actually understand how to do all three methods. So I just want to point out my little radical symbol here. The big mistake that people try to make here is they try to make find the square root at the very beginning. That doesn't work, okay? You have to isolate the variable first, then find the square root of both sides. Remember, when you find the square root of a fraction, you're just finding the square root of the top and the bottom. And then you have to remember, when you find the square root of both sides of an equation, you have to account for the fact that there's a positive number and a negative number that can go in for x, hence the plus or minus 5 over 2. okay? Here, this factored into a difference of squares. You just set each of your factors equal to 0. You solve those two linear equations, and you end up just getting your two answers separate, right? If you wrote your answer as -5/2, comma 5/2, or just like this, that's totally fine, but I just want to point out that these guys are opposites, so they can be combined into plus or minus 5/2. All right, now the quadratic formula here, there's a lot of room for mistakes here. So the 0, remember if you're missing a term, you have to plug 0 into the formula for that term, right? So I end up having negative b, the 0 is neutral, so it can't be negative or positive. So I just put a 0 here, okay? I filled in all of the stuff. You have to remember that when you're subtracting a negative, it ends up becoming a positive, right? So 0 plus 400 gave me 400. The square root of 400 is 20. So now what I have is I have the problem 0 plus 20 over 8, which is going to give me positive 20 over 8. And then I have 0 minus 20 over 8, which is going to give me negative 20 over 8. So I just wrote it as plus or minus 20 over 8, and then 20 over 8 does indeed reduce to 5/2. All right, so there's your work for all three of them. Good luck on your practice. It's important that you do as many of the practice problems as you can because all of them are slightly different. All right, let me know if you've got questions. Good luck.